Okay, so to find the domain of a composition of functions, you have to first find the domain of the two functions individually, then find the domain of the composition of the functions, and then take the most restrictive union of all those domains. So if it ever says, for example, in G, we can never have G x less than 0. That would carry forward even though f of g is equal to 9 minus x. And clearly in 9 minus x, we can have something that is less than 0. But since we first evaluate g of x, we have to take the more restrictive domain. So we first note that x can never be less than 0. So this is bad. So x then has to be x greater than or equal to 0. Over here we don't have any restrictions. We're not divided by 0, taking the square root of a negative number. So the only restriction for f and g is x has to be greater than or equal to 0. So when we find f of g of x, we again don't have any restrictions here. So our final restriction on our domain is that x has to be greater than or equal to 0. There we go. I also state here that the bound is not restricted further by the composite function, meaning that there aren't any restrictions on 9 minus x. Okay, so number 54, f of x equals square root of x plus 2. So first thing we note, taking a square root has to be greater than or equal to 0. G of x, no restrictions. So f of g of x is equal to f of 25 minus x squared. Plug that into here, right? And we get out 25 minus x squared plus 2. Do I say to actually? Oh, it says, I'm sorry. It says to sketch the graph, not find the domain. Okay, so we notice here that we have a square root of 25 minus x squared. If we disregarded this plus 2 here, and we had y equals square root of 25 minus x squared, if we take a square of both sides, and then add x squared, right, onto the left-hand side of the expression, we have x squared plus y squared equals 25, which is the same thing as 5 squared, right? So this is actually the equation for a circle, right? So if it didn't have this plus 2, we would have a circle, right? Well, actually half of a circle because we're only taking the positive root. Then when we add in the plus 2 here, right, we raise the whole thing up by 2 values. Now, remember that our domain had a restriction on f, had a restriction that x had to be greater than or equal to 0. So the domain in our final function here would still be the same. So we would only plot the right part of the graph. Okay. Number 55. It says sketch the graph of f of x equals square root of x plus 2 plus 4. Alright, well, the square root of x plus 2 plus 4. Okay, so if it was just f of x equals square root of x, we have a graph that looks like this, right? Horizontal and vertical shifts from precalc tell us that we can also replace x anywhere in the function by x minus h, and it will translate that function left or right by h units, whatever h is. So if h is a positive 2, we would go to the left 2 units, right? So this function, right, which is square root of x, would be the same thing as, hold on one moment, erase that, would be the same thing as square root of x plus 2, but the square root of x plus 2 is shifted to the left 2 units. Right? Then vertical shifts tell us that if we quote-unquote tack on a constant value v, actually it could also be variable too, but we'll just consider it constant for right now, the graph will shift up or down by a value of v. So in our case, our v is plus 4, so then our x square root of x plus 2 shifted up 2 units, or excuse me, 4 units, give us out something that looks like that. So I show you that right here. I did it again. I show you that right here. Right? We have this function, square root of x, shifted to the left 2 units and up 4 units, giving us this. All right, number 56. Okay, so we have f of x equal to square root of x, and g of x equal to, or excuse me, f of x equal to the absolute value of x, and g of x equal to the square root of x plus 1 minus 3. So this g of x is very similar to what we saw in problem number 55. It would be the square root of x, which looks like this, only it would be shifted to the left 1 unit and down 3 units. So it would look like something like this. Okay. The absolute value function says that any time that you take, and I'm going to erase my original function here, and now we're just going to consider this new function, which is g of x. Any time that you have a negative number, you make it positive, right? So it's just like a reflection about the x-axis, right? So any negative value here gets shifted right on up, so this is 3 units, to the other side as a positive value, right? So a negative value here gets shifted up to a positive value here, a negative value here gets shifted up to a positive value here, a negative value here gets shifted up to a positive value here, and we continue this all the way until we get to the 0 of the function, right? And then positive values of x, you just return back positive values of x. So we get this, right? So that's what I show you right here, right? We start off at a negative 3. It turns out that there is a 0 at x equal to 8, and then the function goes on to look just like it normally does. So that is number 56. Let's do number 57. I'll save that for a new video. Number 57 is very similar to number 52. For x less than negative 2, we want to plot the function 2x, right? Looks like that. If it was the whole domain, if it was just f of x equal to 2x, it would look something like that, right? Where it would cross at x equals 0. Oh, sorry, at 0. Oh, let's actually erase some of that. Plot it right. So 2x looks something like that, right? But we only plot it for x less than -2. Now the reason that I don't have a little whole sign here, right, is because at -2, 2x is equal to -4. Also, in the next function that is valid from the range of -2 to 2, -2 minus 2 is also equal to -4. So the two values correspond here, so that's why we draw a little filled in circle versus a hollow circle. And then that function between of x minus 2, it looks like that, between -2 and +2. And then -x minus 2, right, which if it was the whole thing would look like this. Then continues on for x greater than 2 in this way. And we have a whole, right, at that value because the function is not equal to, let's see, that would be 2, it would be -4. It's not equal to -4 at x equal to 2. It's equal to this value up here. All right, we'll save 58 for the next video.